All right, guys, a few more topics from section 1.5, the first of which is that complex zeros are always going to be in the form x equals a plus or minus b times I. So if we're given a complex zero of 2 plus 3i, there also must be a complex zero of x equals 2 minus 3i. Okay, that one's pretty simple. The next topic, kind of similar to this one, says that the degree of a polynomial is going to equal the sum of the real and the non-real multiplicities. The sum of the real and the non-real multiplicities. So let's say, for example, that you have zeros. You know you have 3 real zeros. This one has a multiplicity of 5. The other two have a multiplicity of 1. But you're told that the degree is 7. Okay, and so it should work out where if we added all the multiplicities together, it gives us the degree. And so if we add 1 plus 1 plus 5, we get 7. The reason it doesn't equal the degree here is because there's non-real zeros. Well, how many are there? Well, 7 plus x is going to equal 11. So there's going to be 4 non-real zeros because, again, the total degree here is 11. All right, next, you could be given a table. You could be asked, is the function linear, quadratic, or cubic? All right, so what we do here is we use what's called successive differences. And it's similar to finding a rate of change, where we ignore the x's as long as they're equally spaced apart. And so instead of doing the change in y over the change in x, we just look at the change in y here. And so from 4 to 8, the function increases by 4. From 8 to 12, it increases by, or 8 to 20, it increases by 12. And from 20 to 40, it increases by 20. So if the function was linear, all of these numbers would be the same. But if we repeat that process, again, we can ignore the x's because they're all equally spaced out here. If we repeat that process, from 4 to 12 is 8. And from 12 to 20 would be also 8. So because this second row here, these are the same number, that's going to make it a quadratic function. Okay? If they weren't the same, we would do it again. And if all your numbers in the third row are the same, then it's going to be a cubic function. All right, even and odd functions. It's been a while since we've talked about this. So even functions have y-axis symmetry. That's going to look something like this. Doesn't have to be a parabola, but it's going to look like that. And we know that f of negative x is equivalent to f of x. Odd functions, on the other hand, have symmetry about the origin. It doesn't have to pass through the origin, but it does have to be where we could rotate about the origin, half of the graph, and it's going to end up right here. Okay, you could also view it like there's 2 reflections. Okay, so if I reflect the left half of the graph about the x-axis, it would look like that. And then if I reflect it over the y-axis, it would be on top of this one right here. Okay, so that's origin symmetry. Odd functions have symmetry about the origin. We also know that f of negative x is equivalent to negatives here. How do we determine if these functions are even or odd or neither? Well, given f of x, I would first figure out f of negative x. Okay, if these two are equal, it's even. If they're not, I'm then going to look at negative f of x. If the bottom two are equal, it's odd. If none of them are equal, then it's neither. Okay, so let's start, again, we're given f of x. Let's figure out f of negative x. So I'm going to replace this x with a negative x. But if I square this, right, squaring a negative gets rid of it, so it turns it back into positive x squared minus 4. And so if I look at x squared minus 4 right here, that is equivalent to this. And so that tells us, hey, this is an even function when that happens, even function. But in the next example, if I were to replace both x's with a negative x, it would look like this. 3 times negative x to the 5th minus negative x. A negative to an odd exponent does not get rid of the negative. And so that could simplify into negative 3x to the 5th plus x. Okay, and so f of x and f of negative x are not equivalent, so it's not going to be an even function. Now I'm going to look at negative f of x. So what that does is we put a negative parentheses, and I'm just going to take the original f of x function, drop it into this parentheses. This is how we do negative f of x here. Okay, now I'm going to distribute the negative, and so we get negative 3x to the 5th plus x, and these two are equivalent. So when f of negative x and negative f of x are equal, it is an odd function right there. All right, that's it for 1.5. So you guys, again, should be able to do the rest of the practice now.